So good morning, bonjour. Before we start, before the first slide comes, I have to confess, I have two handicaps here today. The first handicap is that I come from Austria. That is a country that is not necessarily well known for its impressive coastline. The second handicap I have is, and now it gets even worse, that I'm a lawyer by training. So now you ask yourself, what the hell does a lawyer from a landlocked country on the stage of an international Mediterranean scientific conference? Well, because I want to tell you something about space and the oceans. I've been working for more than a decade now at the European Space Agency in the Earth Observation Directorate, and one of the main reasons we are here today is because I want to tell you about machines like the one you see here on the left side, satellites. Now, let me be clear, I'm sure some of you, maybe many of you, are working already in their daily scientific life with data from satellites. But maybe some don't, although they could. So the reason for this 10, 12 minutes of talk I give to you is to show to those who don't yet use satellites that there might be an opportunity to look at Earth, to look at your scientific subject, oceans in whatever form, from very, very high above. Now, this first panel is called infrastructures, and space infrastructure is something that is not cheap, not easy to do. It needs a lot of development time. What you see here on the left side is one of the biggest environmental satellites that were ever launched into space, called ENVISAT, the environmental satellite, a European satellite. And you see it here in 2002, just before launch. It's being put under a lot of stress to see if it can survive the launch. Such a machine costs in average about 2,000 million euros. Thank you to all of you as good taxpayers to have provided some money for that. But jokes aside, space infrastructure is something that is very complex, however also incredibly useful. You have to bring it, of course, into space, and space is far away. Actually, it is about 100 kilometers above our heads. That's where we say space starts. And a typical Earth observation satellite is put in about 800 kilometers altitude. That's where we observe Earth from. Now, why is that important for oceans? I think it's already obvious to think that a satellite circles our planet in about 90 minutes. We've heard before, one ship at one place at one time, one satellite in 90 minutes, 1.5 hours, that's about the time of this panel, has circled the entire planet once, and is doing that in the next 1.5 hours a second time. Of course, only covering a small strip, the ground swath, ground track, but in about 30 hours, 40 hours, 50 hours, you have covered the entire Earth, and then you start again. So you have a unique advantage. And oceans, I think you will agree with me, are vast areas. And it's not simple to get a glance on all of them in a very short time, on everything. So this is why space is a unique vantage point for getting scientific evidence, for getting data and then scientific evidence. I show you just some examples of the European Space Agency, data we've been working with recently and missions. Here you see one of our missions, not an ocean mission in principle. It's called GOCE, the Gravity and Ocean Current Explorer satellite. Since 4 years in space, and by the way, it will come back, fall back on Earth in about 2 weeks from now. We can't say yet where, so mind you, most of it will burn in the atmosphere. This satellite, GOCE, has provided incredible data input to a lot of scientists on obtaining the most accurate geoid we have so far. And that is, of course, fundamental also for a lot of areas in ocean science and marine science. For example, with the GOCE geoid, we can derive for the first time global currents directly from altimetry data from satellites. And what you see here are just two examples, the ocean dynamic topography, and here the water surface velocity. You see the Gulf Stream nicely in the image on the right. Another mission we have is dedicated to ocean salinity and soil moisture in the land. And here you see one of the first global ocean salinity maps that were produced with the help of this satellite that is also in space since 4 years. Now, these are two tiny examples of two rather small missions of the European Space Agency. By the way, such data can also be combined with other satellite data, and they help you to understand certain phenomena or do pre-warning. We have talked about natural disasters also. Here you see one of the most devastating hurricanes, you remember last year, Hurricane Sandy. And with SMOS, actually, we were able to get reliable estimates of surface wind speeds in this storm. And you see here the time lapse on the left, and you see here on the bottom an optical image from this hurricane over the United States, and you see the gigantic size of it, because these are things you really only see from space. Now, the exciting thing is you can put several mission data types together and derive scientific products and derive new insights in what your area is eventually. Like here, for example, for the ocean, we have altimetry maps from satellites. We have this high-precision geoid I was talking about before. We have data from the Arctic, ice volume, not only extension, but ice volume for the first time, ocean currents, ocean dynamic topography. So you can merge data from various sources. Now, this should be also a little practical tutorial, because very often when we give these sort of presentations, people come afterward and say, well, nice, but where do I find that stuff? How do I get to the data? Because we should be practical. So let me tell you very briefly how you could get data that could be interesting for your research. For example, it's a little hint, go to a website from the Committee on Earth Observation Satellites, CIESM. And there you'll find a huge database on all satellites that are observing Earth, and that includes the oceans and all other water surfaces, the mission, the instrument types, the products, and how you can get these data. For example, here you see agencies, space agencies that is, missions, instruments, measurements. And I just went for you on the multi-purpose imagery for ocean. And you see here, you have fields like ocean color, ocean biology, salinity, ocean surface winds, ocean topography and ocean currents, wave height, surface temperature, sea surface temperature, etc., etc. And you go in each one of these fields and you find all space missions, all satellite missions that are currently in space, that are planned to be put into space in the next month or years, that are planned to be developed in the coming years. You see here in dark blue what is already in space right now and can be used for multi-purpose ocean, the field, satellites that are planned to be launched, etc., etc. And here you see this is just some of the satellites we have at the European Space Agency. And you see here the number of users. We have almost 5,000 scientific projects already that work with data from our satellites, and every day it gets more and more. By the way, not only missions that are currently in space are interesting, but also so-called historical missions. We have now over 4 decades of satellite observations, and you can get these data, and time series is something that is very, very important. Let's also look in the future. We have in Europe a very, very interesting program that was called for many years GMES, Global Monitoring for Environment and Security. Now it's called Copernicus, because that sounds somehow nicer, some people think. And Copernicus is to set up a space and ground infrastructure to observe Earth in a way never done before. And that includes the ocean. Here you see, there are several services. One is the marine services, then you have land services, atmospheric, emergency services. For you interesting, the marine services, that is currently provided through MyOcean 2, the FP7 project. And here you see the domains where satellite data should help to get better insight. Marine safety, marine resources, marine and coastal environment, seasonal and weather forecasting. This is one of these classical sea surface temperature images derived from a satellite. Now, in order to provide those data, we have to put a lot of new satellites into space. And we've been working the last 10 years, basically, on developing these satellites, building them with European industry. And the first one is already ready to be launched on top of its rocket in a couple of months, Sentinel-1. We call them the Sentinel missions. 5 families, Sentinel-1, 2, 3, 4, 5. And specifically of interest for you are the Sentinel-1 mission, a radar mission, all-weather day and night measurement of sea ice, for example, but also other applications. And Sentinel-3, that's really the marine mission, sea surface temperature, currents, altimetry, ocean color, and near real-time data. This is very, very important. You see here an image of Sentinel-3. Last but not least, how do you get these data? Because it's nice to hear about that this exists, but you need a practical guidance, how to get the data. Well, there's something called data policies. The data policies essentially say how you can get the data under what conditions. And I'm happy to say that there's a worldwide trend towards free and open, very important, free and open use of satellite data. That means if you want satellite data for your research, you most likely don't have to pay, and you can get them relatively fast via internet within hours or maximum days after you applied for them. In ESA, we have that free of charge and for everyone. With a few exceptions, if you want to use it for commercial products, then we have to talk about it. But that can be done. This is my second last slide, and it shows you simply some practical entry points. If you have not yet been using satellite data and you think that could be something useful, try out one of these links and read into the matter a bit, like a general introduction, what satellites can do for you, for ocean science in all kinds of aspects. And then you could go to our European Space Agency EarthNet Online Data Access Gate, and there you can register for obtaining any kind of data you want to have. And I don't want to be chauvinistic here, it's not only about the European Space Agency, all other space agencies have also satellites, NASA, French Space Agency, the Japanese, the Chinese, everyone. It's on you to find a way through this jungle and get what you really need, but don't forget, the view from space is a unique one, and this is this last view, and it's a video. I hope it works. It did before, but usually when audience is in the room, it does not anymore. So we'll see in a moment. It's simply an illustration what space can do. You see here the west coast of Africa on the right side, and on the left side, Latin America and the Caribbean here, the Atlantic Ocean. And we'll see here, you see a sandstorm developing over the Sahara. And we'll see now in 10 seconds how this sandstorm is pushed out over the Atlantic Ocean, not a couple of hundred of kilometers, but actually all over the Atlantic Ocean to the other side, several thousand kilometers. And this is only visible by satellites. Ah, it works. Cool. So you see here the sand plume getting out, and it travels all across the ocean, viewed by satellites from 800 kilometers above until it hits here, the Caribbean islands, the Antilles, etc., etc. So this is just a little illustration, because you should always end a presentation with a nice picture or a video. So this was it. Try to get data from space to enrich your work. If you have any questions, further questions, please turn to us. And with that, I thank you for having listened to Space Infrastructure for Oceans.